So far we learned about the rational number and how to find the rational number between two given rational numbers. Now let's learn about the decimal expansion of it. So decimal expansion of rational number is classified into two ways. That is, terminating means that will stop, that will end, or non-terminating that will not stop, right? And it will repeat. So for terminating we can take an example of 1 by 2, that is 0.5, right? You're not going to get any digits after 5, that's it, 0.5. And for the non-terminating you can take an example of 1 by 3, that is 0.66666, and generally we write 67 and stop it, right? So there are basically two types, that is terminating and non-terminating. Now let's do the decimal expansion of few rational numbers. Let's start with the first question, that is 7 by 5. So I'm taking here 7 by 5 and I want to get the decimal expansion of this number, this rational number. How shall we approach? Remember, numerator will go inside dividend and 5 will be divisor. So let's start. 5 ones are 5 and 2 as the remainder. Now what to do? So in this case we'll put the point over here and in the quotient as well. We'll borrow 1 0. So let's bring that 0 down. 5 4s are, that is 20. Then 0. So decimal expansion of 7.5 is what? 1.4. Very simple. We just need to divide like this, right? Let's discuss about the second question. The second number is, we have 145 by 8. So let's write 145 by 8. So let's start with that. 145 and 8 over here, right? So 14 is there, so I think 8 ones are 8, and if we subtract, that is 6 over here, bring down the 5. 8 8s are, that is 64. Subtract and 1 here. Now it's not possible, so put point over here in the quotient as well. 0 over here, let's bring down that 0. 8 ones are 8, right? Subtract 2. Now still not, we want to get the basically no remainder, so let's keep doing it. 0 over here, one more extra 0, so 8 2s are, that is 16, minus and 4 here. Let's take one more 0, that is 8 5s are what? 40, and we get the remainder 0. Done. So what is the decimal expansion of it? That is 18.125. That is the decimal expansion. Now let's do one more question, that is 13 by 4. Let's take 13 by 4 over here. So let's start. 13 inside and 4 over here. So 4 3s are 12, we know very well. Subtract and here 1. Now remainder 1, let's borrow 0, here decimal and here as well. So 10. 4 2s are, that is 8, minus and 2 as the remainder. Let's borrow one more 0, so 0 over here. 4 5s are, that is 20. So we get the remainder 0. Done. So what is the decimal expansion? That is 3.25. Very simple it is, right? You just keep doing it till you get the remainder 0. Sometimes it's going to happen, you're not going to get the remainder 0, 1 by 3, right? The case we discussed, right? So you just keep dividing and you do till you get the remainder 0. Let's discuss few more questions. Let's discuss further. So let's take number 23. First of all, let's take 100 divide by 11. Okay, so let's start with 100 and 11 over here. So if we take 2 digit, it will not work out. So let's take 3 digit, that is 11 9s are what? 99. So if you subtract, you are going to get what? 1 as the remainder. Now, so let's put point over here in quotient as well, and let's borrow 1 0. If we borrow 1 0, we are not able to divide it, right? So whenever we are not able to divide, put 0 in the quotient as well. Now let's borrow one more 0 over here, right? I think yes, 2 over here. So that can work out. 11 9s are 99, right? Now let's subtract and 1 over here. Let's borrow 1 0. So 10. This is same as the previous case if you observe, right? So we'll put one more 0 over here. Let's borrow one more 0 and 1 over here. so that is 9s are, so 99 and minus, so 1 again. So I think even if I do one more time, the same is going to come. 1 0, not able to divide, then one more 0, so we are able to divide, that is 9s are again, so 99 minus and 1, right? So it is going to repeat 0 point, right? 9.09090909, it is going to come again and again. So in that case we can write that 9.09 over bar, because 09 is going to repeat again and again and again, right? You are not going to get the remainder 0. This is the type of non-terminating, not stopping, right? This division is not going to end ever, right? So we write this kind of decimals in this form. Let's discuss one more, that is 23 by 16. So let's start with that. 23 inside and 16 over here. So let's start 23, right? Less than or more than 16, so and less than 32 as well. So once I will work, that is 16 ones are 16 over here and subtraction. So you have 4 and 3, that is 7, right? Obviously we need to borrow. Let's put the point over here. 1 0 over here and 1 here as well. So 16 fours are, that is what? 64. So let's write 64 over here minus, and if we subtract, we are going to get 6 over here. Then now let's borrow one more 0, so 60 over here. Now 16 threes are 48 and 16 fours are 64. It is exceeding, so threes are we need to take. So 16 threes are, that is 48 minus over here. So we are going to have 12 over here. Obviously we cannot divide, right? So let's take 1 0, 120. Now 16 fives are is what? 80, right? 16 sixes are, that is 96. 16 sevens are, that is 112. So let's take 16 sevens are, that is 112, and let's do minus over here. So I think we are going to get 8, and let's borrow one more 0, so 0 over here. Yes, 16 fives are, that is what? 80, right? Minus and 0 over here. So what is the decimal expansion of this one? That is 1.4375, right? Very simple it is to keep dividing. You need to have the good knowledge of the table, specifically when you have the 2-digit numbers as the divisor. 11 is easy as well, 16 as well, right? So this is how we find the decimal expansion. Let's do one more question. So let's start with that. Let's say we have 155 over here, divide by 18, right? So let's start with division. So 155 and 18 over here, right? So 18 stable, I think 18 eights are, that is 144. So let's write 18 eights are 144 minus, and here we have 11. Let's borrow 0 decimal here and here as well. 1 0 here and here as well. So 18 sixes are, that is what? 108. So let's write 18 sixes are, that is 108. So if we subtract, we are going to get 2, and let's borrow 1 0, that is 20, right? So 18 ones are, that is what? 18 and minus, so 2 here, right? Let's borrow 1 0, so 18 ones are here, 18 again, right? Minus, and let's say 2 0 and 0 and 0 as well. Ones are and 18. So if you see over here, we are keep getting 2 again and again and again, right? So it's not going to terminate, right? It will be non-terminating, right? So we can write that which number is being repeated. See, only 1 is being repeated out of 61. So we can write 8.61 bar. Bar will be only over 1 only, right? The reason behind that, because 1 is being repeated again and again. Whichever digit is being repeated, put bar over it. So this is how we do the decimal expansion of the rational number. Now let's discuss one special question related to this. Let's discuss one very important question, and simple as well. Let's start with the question. You know that 1 by 7 is equal to 0.147287 bar over all the numbers after point, right? And we need to predict the decimal expansion without actual division for 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. You can find for any of it. We'll just do for 2, 3, right? We'll get an idea. So first of all, let's start that what's given in the question that is 1 by 7 is equal to 0.1428, then 5, 7 and bar over all of them. We need to find the value of what? That is 2 by 7. We need to find the value of 2 by 7. Now see, if you can understand the logic behind finding the one value, you can find n number of values for this. So how am I going to write this 2 by 7? I will be writing 2 multiply by 1 by 7, right? We learned this in rational numbers. So we know the value of 1 by 7, that is what? 0.142857. We just need to multiply by 2 and we will be done with the value of 2 by 7. So 2 multiply by 0.142857 bar, right? So let's multiply 142,857 multiply by 2. Very simple. 7 2s are, that's 14, 4 carry over 1, 5 2s are 10 plus 1 11, 1 and carry over 1, 8 2s are 16 plus 1 17, 7 carry over 1, 2 2s are 4 plus 1, that's 5, 4 2s are 8 and 2 over here. Done. So what will be the answer of this one? So let's write over here, that is 2 by 7 will be 0.285714 and bar over it, right? Very simple. If we want to do for the 2 is done, let's do for the next, that is 3 by 7, or let's do 5 by 7, just any number, 5 by 7. So here also I can express as 5 multiply by 1 by 7. So basically we are supposed to multiply 5 with this one, that is 0.142857 and bar over here. So let's start with the product over here. So 142,857 into, we are dealing with the 5 over here. So 7 5s are 35, 5 over here and 3. 5 5s are 20, 5 plus 3 that is 28, 8 and carry over 2. 8 5s are 40 and 2 that is 42, 2 over here and 4. 5 2s are 10, 10 plus 4 that is 14, 4 carry over 1. 4 5s are 20 plus 1 that is 1 and 2 over here, and 5 1s are 5 plus 2 that is 7. So answer of this one is 0.714285 and bar over it. That's the 5 by 7. Similarly, if you want to find for the 3 by 4, that is 6 by 4 by 7 or 6 by 7, you can find in the same manner. Very simple way it is, right? So you have these value already given into the question. We are not supposed to do division. We did multiplication over here, first with 2, then with 5, then you can do with 3 as well, then 6 as well, or 4 as well. So this was the topic of the converting rational numbers into decimal. Now we are going to learn for the reverse matter. You have the decimal and you need to find the rational number for that.